Sketch a graph of the function on your calculator. Identify the critical number, whether it represents a local min or max or a point that's not differentiable or none of the above. Critical numbers can do those things. And then sketch a graph and find the value of the local min and max if they do exist. So let me show you what I want you to do. Problem A, what does that graph look like? It looks like a parabola. It does, okay? And if you were to graph it on your calculator, and if you want to graph these by hand instead, you sure can. But I want you, the reason why I want you to graph them is so that you can get a visual representation for whether or not it has a local min or max. Just because there's a critical point or just because the derivative is equal to 0 doesn't necessarily mean that there is a local min or max. Okay, so we see that graph. I'm just going to sketch a very generic graph like that. When I take the derivative, will I find that it's equal to 0 somewhere? Will that represent a local min or a local max? Yes. And so that's all I want to do. I will take the derivative of this function. F prime of x is equal to what? Negative 2x plus 6. If I set that equal to 0, I get 2x is equal to 6 and x is equal to 3. So that's the x coordinate for where the minimum exists or where the maximum exists. So a coordinate of 3. How would I find out now what the actual maximum value is? Plug it back into my original function. 3 squared is 9, make it negative 9, plus 18 is positive 9, minus 2 is 7. So that coordinate is 7. So I'm just going to sketch here. I have a local max at the coordinate 3, 7. So that tells me the location. It also tells me the maximum value that it achieves. Do you guys remember how to find the vertex of a parabola? Isn't that what we just did there? Do you remember how to find the vertex of a parabola? You do negative b divided by 2a, right? Watch this just for a second. If you have y equals ax squared plus bx plus c, what's the derivative of ax squared? 2ax plus b. And if you solve that equal to 0, 2ax plus b, if we want to solve for x equal to 0, what would you do to both sides? Subtract the b. Negative b equals 2ax and divide by 2a. So negative b over 2a is equal to x, the location of what you always knew to be. So that works out. You know, calculus shows that to be true. And calculus is useful for a lot of those things, which we'll do later on. So these other graphs are a little bit more difficult. I was able to sketch this one by hand. I was able to sketch C by hand. D, I had to use my calculator. But that's what I want you to do. And note that just because you have a critical point doesn't necessarily mean there's a local min or max. You have to look at the graph and identify. Please flip it over the backside so we can talk about what we did yesterday. We will do 2 problems on the back, and then you can start working. Problem 2a says, applies Rolle's theorem. And Rolle's theorem says this. Number 1, the function has to be continuous and differentiable. I've given you all functions that are continuous and differentiable over the given intervals, okay? So those 2 qualifications are taken care of. The third qualification is it says that f of a must be equal to f of b. And that if that's true, then somewhere in between, f prime of c is equal to 0. So let's make sure that the heights are the same somewhere. So we find f of a and f of b. What is f of 0 for this function? Equals 1. Good. What is f of 2? 2 squared is 4, minus 4 is 0, plus 1 is 1. So those are the same. So now we can apply Rolle's theorem. It says if it has the same height, then it must go down and come back up, or it must go up and come back down. So you must have a derivative equal to 0 in the middle there somewhere. So we want to take the derivative of this. F prime of x is equal to what? 2x minus 2, and we'll set that equal to 0. So 2x is equal to 2. Divide by 2, x is equal to 1. So it claims that 1 is the point at which the derivative is equal to 0. We could check that with our calculators, but I just want to teach you just some notation. Your book doesn't do this, but I want you to. This is good. I'm just going to write 1 is in. That kind of weird E symbol is in 0, 2. 1 is the point that exists in 0, 2. That's in that set. I found the number that's in that set. And so you can just write the number that's in the set. You're going to come up with numbers for these other 3 problems that are not in that set necessarily. You want to define the one that is in the set. So let's say we would have come up with -8 here. I would have excluded the value of -8, just said 1 is the number in that set. Because notice I came up with x equals 1. Well, I should check to make sure that's in there. And I did. And I've set it. And I'm done. So you can do that for B, C, and D. And then 3 is the mean value theorem. The mean value theorem does not make us state that the outputs are the same at that height. All we have to do is just verify that it's continuous and that it is differentiable. And in fact, I've only given you functions that are continuous and differentiable. It says satisfies the mean value theorem. I don't know if you remember from yesterday, but the mean value theorem says this. There exists some point C such that if you take the derivative of it, it's equal to the mean value, which is simply our slope formula. So what that's telling me to do is take the derivative of my function. What's the derivative of my function? 2x plus 2 equals f of b. Now note b is the second point, not the first point. So b would be 1. F of b would be 1 minus, what's f of a? Minus 9 over b minus a, or 0 minus -4. So I've set up the mean value theorem. And again, what it's saying is that if I have a graph, okay, and I look at the average slope over a given interval, there is some point on that graph such that the derivative is equal to that average slope. That has to happen somewhere. So we're going to verify that that does in fact happen by solving for this. Namely that 2x plus 2 must be equal to -8 somewhere. Or I'm sorry, -2, correct? And I solved that by subtracting 2. 2x is equal to -4. Divide by 2. X is equal to -2. Is -2 in our interval? It is. -2 exists in -4, 0. It lies within there. That is the point that I'm looking for. So once I find the average value, I set that equal to the derivative to find. So we found this point C. Point C is -2. That is the value within the interval where the derivative is equal to the average value. Question? Yeah, I would like you to write that. Because otherwise what's going to happen on the test is that what you'll do is you'll actually find a number of answers, and I don't want you to forget to actually identify in the end which one sits in the interval, because that's the most important piece. This is what I want you to work on today. You have the rest of the hour to work. I do have an answer key, which I've double checked, so hopefully we should be good to go. So go ahead. Goodbye, Stuart.